In this video, let's take a look at a set of 10 different practice problems dealing with math concepts for 6th grade. While I have some other videos and practice problems where we can use a calculator to solve different types of problems, for this particular video and worksheet, let's focus on 10 different problems where we won't use a calculator. Real quick, if you'd like to download a free copy of this blank PDF as well as the annotated answer key PDF, you can find a link to that in the description box below. Let's jump right into it. For question number 1, in a particular pottery shop, there are 8 blue pots, 12 yellow pots, 15 green pots, and 10 white pots. For every 48 yellow pots, the question is how many green pots would there be? So let's go ahead and see how we would set this up. So we are being asked about these green pots, and we do know that there are 15 green pots over here, so maybe we can set up a ratio. So I'm going to go ahead and write green over here. Just go ahead and label what is going on. And let's see what other color we have going on here as well. It seems like the information about the 48 yellow pots should be important to us, and there are 12 yellow pots over here. So let's go ahead and find the ratio of maybe green to yellow here. Now, how was the ratio originally? Well, there were 15 green pots originally, and so the ratio of green to yellow is going to be from 12 to 15, or 15 to 12 rather. And here we're being told that there are going to be 48 of these yellow pots, so let's put 48 on the bottom here. And the question is how many of these green pots would there be? So let's go ahead and maybe use a variable if we don't know what that is. And so if we have an original ratio of 15 to 12, we need to find an equivalent ratio over here. Looks like from 12 to 48, we have 4 times more of the yellow pots. So that means that if we have 4 times more of the yellow pots, we should have 4 times more of the green pots to keep the same ratio. And so 15 times 4, that's going to be 60. So there would be 60 of these green pots if there were 48 of those yellow pots to keep the same ratio. For number 2, we have a desk that has an area of 14 2/3 square feet. We're assuming that this is a rectangle. And so if we have a rectangle forming over here, we know the area, or the inside of this, the area is going to be 14 2/3 feet squared, or square feet. We know the length is going to be 3 2/3 feet. Let's go ahead and write that in, 3 2/3. The question is what is the width going to be? That's going to be over here. Okay. Now the formula for area is, for it's a rectangle, it's going to be length times width. Now the area in this case is going to be 14 2/3. Let's go ahead and substitute that in, 14 2/3 feet squared. And that's going to be equal to length. The length is going to be 3 2/3 feet multiplied by the width, which we don't know what that is. I'm going to write W. Okay. If we know that 3 2/3 multiplied by W is equal to this 14 2/3, then we should use the division property of equality here. I'm going to go ahead and rewrite this using improper fractions. So 14 times 3, that's going to be 42, plus the 2 on top, that's going to be 44. So this is going to be 44 over 3 feet squared. And then on the right side, 3 2/3, 3 times 3 is 9, plus the 2, that's going to be 11. So that's going to be 11 over 3 feet. And then that's going to multiply by W. Okay, so let's go ahead and divide both sides by 11 over 3 feet. Do that to both sides of this equation, so we keep things nice and balanced here. On the right side, 11/3 divided by 11/3, that's just going to cancel out, right? That's going to become 1. So we're just going to be left with 1, or 1W. And on the left side, let's go ahead and just divide these two over here. So on the side, I'm going to take this 44 over 3, and let's go ahead and divide that by 11 over 3. Now keep in mind, if we are dividing, we're actually going to multiply the first fraction or number by the reciprocal of the second. So let's flip that upside down. Now you could multiply, but we could also cross cancel here. So 3 and 3 will cross cancel to make 1 and 1. That's their GCF. And for 44 and 11, we can divide those both by 11, their GCF, and we're going to get 1 and 4. So multiplying this out, we're going to get 4 over 1. And so the width here we're going to find out is going to be 4. And so we can go ahead and just conclude that the width for this rectangular desk is going to be 4 feet. Here's number 3. For number 3, point A is going to be located in quadrant 3 on a coordinate plane. I'm just going to go ahead and draw a rough coordinate plane here. So here's going to be the x-axis. And then let's go ahead and draw the y-axis, maybe something like this. And so what we're going to do here is let's go ahead and see. We have a point that's going to be located in quadrant 3. So here's quadrant 3. I'm going to call this point A. And what's going to happen is we are going to be reflecting this point. So we're going to go ahead and reflect it across the x-axis. So the x-axis is this line over here. And so if we see how far A is from that x-axis, let's go ahead and just flip it to the other side. So this is going to be A, and you put this little line here, that means it's been reflected. So if we have the x-axis and A was originally over here in quadrant 3, when we reflect it across the x-axis, now it's in quadrant 2. So where's the y-axis? That's this vertical axis over here. Now we have point A prime, which is over here in quadrant 2. Let's see how far away it is from the y-axis. If we reflect it across, it's going to go to the other side, and it's going to be now over in quadrant 1. So we put two little lines, or A double prime. That's now the new reflection of this point A. So it's been reflected twice now. And it looks like we're reflecting it one more time. We're now going to reflect it across the x-axis. So this is the x-axis, that horizontal axis. How far is this A double prime away from the x-axis? Well, however far that is, we're going to reflect it across the other side. And so it's going to be somewhere around here. And so this would be A triple prime, or the final location of point A. And so after reflecting this point A a few different times here, so 3 times to be exact, it is now going to be located in quadrant 4. Here's number 4. For number 4, it looks like we have a long division problem because it says find the quotient, so that's going to be a division problem. If we're going to find the quotient here, it's going to be this 53.406. That's going to be the dividend, and we're going to divide that by the divisor of 25.8. Now, when we do these long division problems, we don't want this second number or the divisor to have a decimal. So if we multiply it by 10, we can multiply both of these by 10. And so that will get us the same quotient in the end. So we can go ahead and rewrite this problem as 534.06. And we're going to divide this by 258. So if we set up this problem, we're not going to have any problems, and we can go ahead and divide normally. So let's go and set up 534.06, move that decimal straight up, and then we have 258 on the side here. All right, now 258 won't fit into 5, and it won't fit into 53 either, but it definitely fits into 534. I think it definitely fits in once. Maybe it'll fit in twice, not 3 times though. So let's do 258 maybe times 2. And so 8 times 2, that's going to be 16, carry the 1. 5 times 2 is 10, plus 1 is 11, carry the 1. 2 times 2 is 4, plus 1 is 5. So 516, that's pretty close here. So let's put a 2 on top. 2 times 258, that's going to be that 516. If we go ahead and subtract here, I believe this is going to be 18. Okay, you can go ahead and pause and check that if you'd like to. Next, I'm going to go ahead and bring down the 0. So if we bring down the 0, that's going to be now 180. Okay, now 258, that's not going to fit into 180, so make sure we put a 0 on top and say it doesn't fit in. So we're going to go ahead and subtract. What's 0 times 258? That's still 0. So 180 minus 0 is still going to be 180. And finally, let's bring down the 6. So it's going to be 1,806. And let's try this one more time. 258 fitting into 1806 or 1,806. I'm thinking, maybe at least 6 or 7 times maybe. So let's go ahead and try 258. Let's try multiplying this by 7. 7 times 8 is going to be 56, carry the 5. 7 times 5 is 35, plus 4 is going to be 40, carry the 4. 7 times 2 is 14, plus the 4 is going to be 18. So it's exactly 1,806. So let's go ahead and put the 7 on top. 7 times 258 is exactly 1806. And if we go ahead and subtract that, then we're going to get a remainder of 0. So the quotient we're going to have here is going to be 2.07. So we knew that the 25.08, this right over here, fits into 53.406, exactly 2.07 times. All right, for number 5, we may not bring luggage that exceeds 50 pounds on a particular airplane. We're going to write and graph an inequality to represent W, the possible weights in pounds of the luggage. Okay, so we can't go over 50 pounds, but we can be 50 pounds. So we have the weight, the possible weight of the luggage. It can be less than or equal to 50. This would be the inequality here. Make sure we include this little line beneath. This means it can be equal to 50 pounds as long as we don't exceed it. Okay. Now, what about graphing it? Well, graphing it here would be something like this. You just make a number line. Okay, so after you make a number line, this is going down forever. This is going up forever. So negative infinity, positive infinity. Then we put 50 right in the middle. and then you can just put a couple numbers bigger. I'm going to go by 5 pounds going up. We can go by 5 pounds going below. And so what would be the possible weights? Well, when you graph these, what you do is you take an open circle or a closed circle. If it can equal 50 pounds, make sure you fill it in or put a closed circle here. And where could the weights possibly be? Well, it has to be less than or equal to 50. So it cannot exceed 50. So we're going to put weights that are less than 50 or equal to it by filling in that circle. Let's check out number 6. For number 6, we have 72,504 pieces of candy, and they're going to be split evenly amongst 36 students. Now, if they're split evenly, that means we're going to be dividing. So let's go ahead and take this 72,504. Let's go ahead and divide that by 36. Okay, so if we do that, let's take all this candy. Let's go ahead and put the 72,504. That's going to be our dividend, and our divisor here is going to be 36. Let's go ahead and put that over here to the left. Now 36 into 7 is not going to fit. Into 72, I think that's going to fit 2 times, right? 2 times 36 is exactly 72. If we go ahead and find the remainder, we're going to find that's going to be 0, right? Let's go ahead and bring down this 5. Okay, so now we're going to see how many times does 36 fit into 5. We should say it doesn't fit in at all, so we're going to put 0 times. So 0 times 36 is going to be 0. 5 minus 0, that's still going to be 5. Bringing down the 0 here, let's repeat this process. So this is going to be 50. 36 into 50, I think that's just 1 time. 1 times 36 is 36. If we find the remainder here, I believe that's going to be 14. And then finally, we're going to bring down this 4. Hopefully this goes in evenly, or else we'll need decimals. That's going to be 144. And I think what we're going to find here is that 36 times 4 is going to be exactly 144. And you can go ahead and check that on the side if you'd like to. And this should be equal to 0 for the remainder. So in terms of how much candy will each of these students receive, they will receive 2,014 pieces each. All right, let's move on to number 7. For number 7, on a coordinate plane map, a bookstore is located at -3, 6, and a coffee shop is located at 9.5, 3. If each unit on a coordinate plane map represents 1.5 kilometers in real life, determine the exact distance between the coffee shop and the bookstore measured in kilometers. Okay, so let's go ahead and just take a look at maybe what this looks like roughly. So here's a rough sketch. Here's the x-axis. Let's go ahead and draw the y-axis in here as well. So here's x and y. Now we're going to go ahead and plot this -6, 3. I believe that's going to be in quadrant 2, right? So we're going to go 6 to the left and 3 up. So this is going to be the bookstore. I'm going to go ahead and put a B for bookstore. And then we have the coffee shop, which is going to be at 9.5, 3. So let's go 9.5 to the right and then 3 up, maybe something like this. So here is the coffee shop. So let's see, the distance between B and C, what we can do is add the absolute value of their non-matching numbers here. So you can see these 3's do match. So we can go ahead and add the absolute value of this -6 and 9.5. So if we add the absolute value of -6 with the absolute value of 9.5, we'll get the total distance here. So this is going to be 6 plus 9.5. That's going to be equal to 15.5 units away when we're looking at this coordinate plane map. Right. The next step here is to think, okay, well, each unit on the map represents 1.5 kilometers in real life. So if we know we have 15.5 units, what we're going to do here is let's go ahead and take that 15.5. Each one of those represents 1.5 units in kilometers. So let's go ahead and multiply it by 1.5. Okay, so 5 times 5 is 25, carry the 2. 5 times 5 is 25 plus 2 is 27, carry the 2. 5 times 1 is 5 plus 2 is 7. Next, we are done with this 5 over here. Let's put a placeholder. And so let's go ahead and take this 1. 1 times 5 is 5. 1 times 5 is 5. 1 times 1 is 1. And if we add these together, 5 plus 0 is 5. 7 plus 5 is 12. Carry the 1. 7 plus 5 is 12 plus 1 is 13. Carry the 1. That's going to be 2. So I think we're going to have 2 decimal places here. And so we have 23.25. And so spelling this out a little bit more clearly, if we had kind of a ratio here of units that are on the coordinate plane to kilometers, which is km, that's written in real life here, we knew that there was going to be, for every 1 unit on the map, that was going to be 1.5 kilometers in real life. And so if we had 15.5 of these units on the map, we had to figure out how did we get the number of kilometers. So from here to here, we're just multiplying by 15.5 since we had a unit rate. And so we had to multiply this by 15.5 also. So that's why we're multiplying 1.5 times 15.5. We just figured out that's going to be 23.25 kilometers though. Okay, so what's the distance between the coffee shop and the bookstore in real life? We're going to say it's going to be 23.25 kilometers, or km. Here is number 8. For this one, we're going to go ahead and select each expression that is equivalent to this quantity where we have 7 times this quantity of x plus 4. Now, what we can do here is we can actually distribute the 7 to see what this would look like without using parentheses and using that distributive property. If we do that, this would be 7 times 1x. There's an invisible 1 as a coefficient. That's going to be 7x. And then 7 times 4, that's going to be a positive 28. All right, so let's take a look at option A. For option A, if we combine this 5x and 2x, which are like terms, then that would be a total of 7x, right? Now, if we go ahead and combine this constant of 20 and this constant of 8, that would be a total of 28. So that's going to be plus, and then that's going to be positive 28. Notice here how this does match what we had initially, right? So we can go ahead and say that this first one does check out. We know that this would be equivalent, right? For the second one, we just have this 7x, and this 7x does match this 7x, so that's good. But this constant of 4 does not match this constant of 28. So since these are not the same, we're going to go ahead and say that this is not equivalent to that original expression. For option C, we do have 7x and 7x, so that's good. And we have 28 and 28 for our constant terms. So based on just using the distributive property, we know that's true. Taking a look at option D, let's go ahead and combine some like terms. So 3x plus 4x, that's going to be a total of 7x. Okay, so far so good. But then let's take a look at the constants. Well, we have 19 plus 19. 19 plus 19, that's going to equal 38. Well, that's actually close because it's got the 8, but unfortunately it's not 28, it's 38, so that one's not going to work. Finally, for E, this one looks a little bit more complicated. Let's see if we can simplify this thing together. So you might notice here that we have 2 of these x plus 4s, and we're going to add 5 more of these x plus 4s. And if that's the case, you can go ahead and say that if we combine those, you could say that there are 7 of these x plus 4s. And at that point, you would know that if this is 7 of these x plus 4s, that's the same thing as this, and you could go ahead and say that E is indeed the same. If you didn't notice that though, you can use a distributive property here, so 2 times x and 2 times 4, that would equal 2x plus 8. And then if you distribute this 5 to this x and this 4, that would be plus 5x plus 20. Now if you go ahead and combine like terms, 2x plus 5x, that's going to be equal to 7x. And then if you combine this positive 8 and positive 20, that's going to be a positive 28. So if you wanted to go ahead and use distributive property, you're going to see that that also matches. And so for multiple reasons, that checks out. So we have 3 choices, A, C, and E, which are all equivalent to the original expression of 7 times the quantity of x plus 4. Here's number 9. For number 9, we have a rectangular prism that has the dimensions of 4 1/3 centimeters by 5 centimeters by 8 2/3 centimeters. We're going to go ahead and figure out how many of these little 1/3 centimeter cubes are going to fit inside of this prism. So I'm going to go ahead and make a rough sketch here. So maybe something that looks like this. Not really going to draw this to scale, but just to help us kind of imagine what we are dealing with here, we just need a prism. So here is a rectangular prism. And maybe along one of the dimensions, we're going to put 4 1/3. That's in centimeters. This is going to be 5 centimeters. And I know this doesn't look proportional, but hopefully this still kind of makes sense. And what we're going to do is we're going to fill this thing with a bunch of tiny little cubes that are each 1/3 by 1/3 by 1/3 in terms of their dimensions here. Okay, so we're going to try to see how many will fit inside here. Now, let's start with maybe the length here. How many of these cubes would fit alongside here? Well, if we go ahead and take the length here, we can say this is going to be 4 1/3, which is also known as 13/3. And if we want to see how many of these 1/3 will fit inside here, we can divide it. But this is going to be the same thing as 13/3 multiplied by 3/1. We can go ahead and cross cancel those 3's to make 1's. And you're going to find out that we could fit 13 of these little cubes going across the length here. That's going to be from here to here. There's going to be 13 of them. Now, what about the width? Well, the width here is going to be 5. So I guess the question is, how many could we fit this way? So the width is going to be 5, or 5 over 1. Let's see how many of these little third cubes are going to fit inside here. That's going to be 5 over 1 multiplied by the reciprocal of 1/3, which is just 3 over 1. And that's going to equal 15. So we can fit 15 cubes going this way. I'm going to go ahead and write that right over here. And then finally, what about the height? How many can we stack on top of each other? So that's going to be the height. Now 8 2/3 is the same thing as 26 thirds. And if we want to see how many 1/3 fits inside of that to stack them, we got to divide. That's going to be 26 thirds times 3 over 1. These 3's are going to nicely cross cancel to make 1's. And so we're just going to be left with 26 of these little cubes are going to be stacked on top of each other. So how many cubes stacking up and down? That's going to be 26. Okay, so how do you find the total number of cubes? Well, there are 13 going across the length. We're going to multiply that by 15. So this will tell us how many are going to be across the bottom. And then once we find that answer, we're going to multiply that by 26 because there's going to be 26 layers of all of those cubes. So let's go ahead and figure out how many are on the bottom layer first. That would fill up the bottom. And so let's do that on the side here maybe. So multiplying 13 by 15, let's see how many would be across the bottom. So that's going to be 15, carry the 1, that's going to be a 6, that's going to be a 3 and a 1. Adding these together, we're going to get 195. So there'd be 195 of these little cubes across the bottom, and there's going to be 26 layers of this thing. So let's take this 195 and multiply that by 26. So I think this is going to be a 0, carry the 3, that's 54 plus 3 is 57, carry the 5, 6 times 1 is 6 plus 5 is 11. Then we have 2 times 5 is 10, carry the 1, 9 times 2 is 18 plus 1 is 19, carry the 1, 2 times 1 is 2 plus 1 is 3, so add these up. Looks like we're going to have 0, 7, 10, carry the 1, that's going to be 5. So by multiplying all the cubes on the bottom by 26 layers, I'm getting that we're going to have 5,070 of these 1/3 by 1/3 by 1/3 cubes. So that's how many of these would fit inside that prism. Something else you could have done if you didn't want to use this method is you could have just multiplied the length by the width by the height and then multiplied that product by 27, and that should also get you this 5,070. You multiply by 27 just because the volume of one of these cubes, 1/3 times 1/3 times 1/3, is 1/27th of the volume of a 1 by 1 by 1 cube. So we need 27 times more of these little cubes. All right, final question. Number 10, Benny purchases a pack of 12 of the same candy bar for a total of $6.49. Then he's going to go ahead and sell each of those 12 candy bars for $1.87 for each of those candy bars. What is the profit that Benny will earn? So let's go ahead and see here. So to figure out the amount of money that he's going to make, let's do 187 times each of those candy bars. So 2 times 7 is 14, carry the 1. 2 times 8 is 16, plus 1 is 17, carry the 1. 2 times 1 is 2, plus 1 is 3. Moving on to the 1 times 7 is 7, 1 times 8 is 8, 1 times 1 is 1. If we go ahead and add these all up here, we're going to go ahead and bring this 4 straight down. 7 plus 7 is 14, carry the 1. 1 plus 3 plus 8, that should be 12, carry the 1. And so I think this is going to be $22.44. This is going to be the money that is made, okay, from just selling the candy bars. But that's not going to be the profit, right? Let's go ahead and remember that Benny had to go ahead and buy 12 of these candy bars, and he spent $6.49 first. So to figure out the actual profit, which is going to be how much he made minus what the expenses were, let's go ahead and take this $22.44, and let's go ahead and subtract what he had spent on that candy to begin with, right? So those were his costs, so minus $6.49. So let's go ahead and do that. Looks like we're gonna have to borrow for 4 minus 9, so this is going to be a 3. We're borrowing, and that's gonna be 14. 14 minus 9 is now 5. Now the 3 doesn't have enough. Let's go ahead and borrow. This is gonna be a 1. This becomes 13. 13 minus 4 is going to be 9. Bring that decimal over here. Now the 1 doesn't have enough. Let's make this a 1. Let's make this an 11. 11 minus 6 is going to be 5. And we have a 1 over here. So what's the profit? Looks like he made $22.44, but we had to subtract the $6.49 that he spent on just buying the candy. Looks like the profit here after taking away the expenses is going to be $15.95. Alrighty, so there you have 10 different practice problems dealing with some 6th grade math concepts. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.